You type a URL and press enter, and then you wait, maybe a second, maybe two. But in that brief pause, an invisible storm is raging. Your single click set off a chain reaction spanning the planet. Satellites, undersea cables, millions of servers, all to deliver a page of text and images. Computers don't understand names. They speak in numbers, IP addresses, strings of digits like 142, 250.80.14. So before anything else, the browser needs a translation. The browser checks its own cache first. Haven't been here. It asks your operating system. The OS doesn't know, so it asks your router. The router asks your ISP. The ISP asks a root server, which points to the .com server, which points to the authoritative server, which finally hands back the IP address. All of this, from your browser's cache to the authoritative server and back, takes between 20 and 120 milliseconds. That's faster than you can blink. Now the browser opens a connection. This is TCP, the protocol that guarantees nothing gets lost. It starts with a three-way handshake. The browser says SYN, are you there? The server says SYNACK, I'm here. The browser says ACK, great, let's talk. That handshake takes one round trip, about 50 to 100 milliseconds. But if the server's on the other side of the world, that's just getting started. And remember, this is only step one of the connection. If the site uses HTTPS, and nearly every site does now, there's another layer, TLS. Browser and server exchange digital certificates, agree on encryption keys, and wrap every byte in a secure tunnel. This takes 2 more round trips. That's 2 to 3 round trips before a single byte of data is exchanged. 100 to 300 milliseconds just to set up a secure conversation. But the payoff is enormous. Everything after is completely encrypted. With the secure channel open, the browser sends an HTTP request. It says, "Get me the home page, here's who I am, here's what I accept." A simple text message that starts a cascade. That request doesn't travel in a straight line. It hops through routers, crossing networks owned by different companies in different countries. It might travel through undersea cables. There are over 400 of them spanning 1.3 million kilometers across the ocean floor, each no thicker than a garden hose. Eventually, the request reaches a data center. A server receives it, likely one of millions in that building alone. The server doesn't just store the page, it builds it. A web server like Nginx hands the request to an application server, maybe running Node, Python, Ruby, or Go. That app queries databases, checks permissions, personalizes content, and assembles an HTML page from templates and data. The more dynamic the site, the more work happens here. The server sends back a response. 200 OK, here's your page. With headers that tell the browser how to cache it, what type of content it is, how big it is. Then the real work begins on your machine. Now the browser takes over. Modern browsers are essentially operating systems. Chrome has multiple processes for tabs, a GPU process for graphics, a networking process, and a dedicated JavaScript engine called V8 that can compile code faster than many native languages. The browser starts parsing HTML the moment it arrives. It builds a tree called the DOM, Document Object Model. Each HTML tag becomes a node. Nested tags become children. Attributes become properties. The page becomes data. As it parses, it finds CSS references. The browser fetches those stylesheets and builds a second tree, the CS-SOM. It figures out every element's size, color, font, position. This is where the page goes from a document to a design. Then comes layout. The browser calculates the exact position of every element. This box is this wide. This text wraps here. This image pushes the footer down. It's actually a complex mathematical constraint problem, and the browser solves it hundreds of times per page. And then there's JavaScript. The browser downloads, parses, and executes it. JavaScript can modify the DOM in real time, fetch more data from APIs, trigger animations, respond to every click and keystroke. Modern pages can run megabytes of JavaScript, executing hundreds of thousands of lines of code. Finally, the browser paints. It fills in backgrounds, draws text, renders images, applies shadows. Then the compositor takes all these layers and combines them into a single frame and sends it to your screen at 60 frames per second. All of this in 1 to 3 seconds. And that's remarkable because the modern web is enormous. The average page is over 2 megabytes, 70 separate requests to 15 different servers. In 1995, a web page averaged 14 kilobytes. A single image on today's web is often bigger than an entire 1995 website. Every search, every video, every page load touches a data center. These buildings contain hundreds of thousands of servers, consume megawatts of power, and require massive cooling systems just to keep from melting. Google alone processes over 3.5 billion searches per day across millions of servers. How is it this fast? Caching. Your browser caches files locally. Your ISP caches popular content. CDN, content delivery networks, store copies of websites in data centers around the world, so your request never has to travel far. The system is designed so the most common path is also the shortest. Of course, this whole system can fail at any point. DNS servers go down, cables get cut by ship anchors, servers overload, your Wi-Fi drops a packet. That's when you see the spinner or a 404 page or the dreaded DNS error. Given the complexity, it's almost surprising it works at all. On mobile, the same miracle has to work with one hand tied behind its back. Mobile networks add 50 to 200 milliseconds of latency. Your phone has less memory and a slower processor. Switching from Wi-Fi to cellular restarts the whole cycle. And yet, it still works. The system keeps getting faster. HTTP/2 multiplexes requests over a single connection. HTTP/3 and quick eliminate the TCP handshake entirely, reducing connections to a single round trip. Even the protocols are evolving to make that 1 to 3 seconds even shorter. Every time you visit a website, you are leveraging an infrastructure that cost hundreds of billions of dollars to build, maintained by millions of engineers, governed by international treaties and constantly evolving. Satellites in orbit, cables on the ocean floor, servers in data centers, software on your device, all coordinated to deliver a single page in under 2 seconds. The next time you type a URL and press enter, remember, you just orchestrated a miracle of modern engineering.